This is a follow-up video to one where I tested various brass conversions for 11mm or 43 Mauser in a Gewehr 1871. But you don't need to watch that one first if you haven't, because to summarize, I tested conversions based on 4570 with an O-ring added to the rim, against two versions of converted 300 Winchester Magnum, one with a snap ring added as the rim, and one with a machined rim glued into place. The converted 4570 brass was the clear winner because it was easy and mostly reliable. However, I want to revisit the latter 300 Win Mag conversion, the one with the glued ring, in this video. Because the ring was machined, I was able to exactly match the dimensions of the 11mm Mauser case. This ensures the headspace is accurate and the extractor is able to function as expected. I decided against this method since it's impossible to make without a lathe, time-consuming, and it's not as durable as expected. When resizing the brass, I ended up cracking the thin rim and getting the case stuck in the sizing die. Annealing the brass beforehand will make it easier to size, reducing pressure on the rim. However, I'm concerned that heat will impact the epoxy's bond, weakening the rim anyway. But can this idea be improved? I came across a web page from Dave Cushman, which I linked in the description. It's based on an article from Guns and Ammo magazine in 1969 entitled Rimming the Rimless. I'm going to give credit for both authors for the guidelines I'll be following, but I'll say it up front. With this process, I'm abandoning any idea of doing this simply and easily. This will require machining on a lathe, which I used to make these, and using these will require some heavy-duty tools. But first I'll discuss what these are. These are swaging dies. Swaging is the act of deforming metal to fit around another part. The metal being formed will be a thin brass ring. The latter, of course, will be this 300 Win Mag case. The ring will fit over the case like so, but instead of epoxy as before, they'll be permanently attached through swaging, the ring filling the extractor groove on the case. That's where these dies come in. They're very simple to make, so I won't go through that process, but in short, the through hole in this larger die allows the case to pass through it. On one end of the hole is a 45-degree chamfer. On the other end, there isn't a chamfer, just a straight cut across. The smaller die has a recess cut into it to fit the case, along with the ring added to it. These three fit together like so. With the ring added around the base of the cartridge, it's inserted into the recess on the bottom die. Then the larger die is added to the top with the chamfer end down. And when pressed with enough force, it will swage the ring to the case, the chamfer pushing the material inwards. I'm not sure how much force that will take, but my guess is a lot. Then I can flip the top die and press with the straight end down to swage it some more. But before I can try these dies out, I need to form the case and machine the ring. I'll start with the case. The first step is to trim to length. I'm using this mini chop saw, which works well for this purpose. Then I can move to the press to form the case. The sizing die doesn't have the expander installed in it. Instead, I'll size and expand in separate steps. With enough case wax, I'll put the case into the press and slowly raise the ram. Next, I'll install the expander back into the die. And lock it in. Then I can expand the neck. I'll add more wax, then expand it all the way. That's the top of the case converted. Now to address the bottom, I'll put the case in the lathe to turn off the belt. But here, unlike in the last video, I'll reduce the rim diameter as well. And I'll also chamfer the top of the rim to match the chamfer at the top of the extractor groove. The symmetrical chamfers on either side of the extractor groove will hopefully provide a ramp for the ring to be swaged into. And now to make the ring, I have a piece of brass that's 5/8 of an inch in diameter, already the size I want for the ring. I'll start by drilling it out. I'll change to a broken end mill I'll use as a boring bar. I'll use the base of the case to test fit. I want a tight fit, so I'll remove just a few thousandths more. And that looks good. It's a tight fit on the brass. Next, I'll swap in the parting tool. To ensure the thickness of the ring is what I want, I have a dial indicator set up on the carriage. I'll touch off the tool and put a drill bit inside to catch the ring. Then I'll zero the indicator to the thickness of the parting tool. Then I can advance the carriage. First the thickness of the tool, then the thickness of the ring, in this case 160 thousandths, and part it off. The parting tool leaves a small burr that can be removed by hand. Here's a close-up of the ring. You can see how its height compares to the extractor groove on the case. However, before forming, I'll heat the ring to make it softer and thus easier to press into shape. After allowing for it to cool, I'll slide it down the case. It's a tight fit, so I'll use the top die to set it so the bottom ring is flush to the end of the case. Then I'll place it on the bottom die, fitting the ring and case into the recess. And add the top die with the chamfer end down. I'm going to use the vise to press these together, like so. However, one thing not mentioned on the website or in the article earlier is what keeps the case head against the bottom die. I think there could be a chance for it to move when pressing, especially when it's horizontal like in the vise. I dug in my parts bin and found this spring, which fits into the case like so. This will keep the case butted up against the bottom die and hopefully unable to move. I'll put the assembly in the vise. And crank down on the handle. Now to see what it looks like. The vise doesn't look like it did too much. Though it is firmly attached now. It needs to be pressed more in order for the ring to be swaged into the extractor groove. I really don't want to break my great-grandfather's vise, so I'll need something a bit heavier. This is a 20-ton hydraulic press, which should be able to apply a bit more force than the vise. I'll add back on the case, and then the top part of the die, starting again with the chamfered end and the spring. The spring makes it hard to get it aligned under the ram, but I got it, and now it's time to press. I'll rotate everything 180 degrees, just in case there's any misalignment in the press. Then I can press it again. You can see how the top of the ring is formed into a cone shape. Now to flip the die to the straight end, and then press it again. The spring probably isn't necessary anymore, but I have it in there anyway. I'll rotate and press again. The die is a little tight, but I got it off. This is interesting. The brass is cracked all around, but only on the top of the ring. More on this in a bit. I need to get the case out of the bottom die first. The brass has expanded, making it a very tight fit now. I think what happened is that the brass not only expanded inwards to fill the extractor groove, it also expanded outwards to the gap between the two dies. That expanded brass became brittle, which is why I can break it off easily. Or at least I can halfway around. I'll check with the calipers to see what the pressing did to the brass ring. The thickness started off as 160 thousandths. Looks like it compressed it as much as 50 thousandths. Where the brass is broken off, that's just under 100 thousandths thick, enough to continue on with the project. The diameter for the part that was held in the bottom die is roughly 0.635, and above it, to where the brass started cracking outwards, is up to 0.650. Remember, this started off as 5/8 of an inch. The next step is to machine the ring in order to form the rim of the case. I'll get the case tightened in the lathe truck. I'll be using the parting tool in order to be able to get into the corner ahead of the rim. Just like before, I have a dial indicator set up on the carriage. I'll touch off the tool on the back of the case, then set the indicator to the thickness of the tool. I'll back it off, then clear the rim. Then I can advance to 0 so that the right side of the tool is flush to the end of the case. Then advance the thickness of the rim, which I'm going to set at 90 thousandths. I'll lock the carriage and start the cut. I'm advancing the cross slide until it just starts to cut into the brass of the case. Now I'll unlock the carriage in order to be able to trim the outside diameter of the rim, which I'll take down just slightly. Then I'll swap out the parting tool in order to clean up the rear of the case. And then put a small bevel on the forward edge of the rim. Then another on the rear. Here's the rim squared up on all three sides, the top, bottom, and outside. I'll bring in what this case started as, an unmodified 300 Win Mag. I outlined the profile of that, then copied it over to the converted case. That means that the rim that's outside of the white line is the ring that's been swaged onto the case. You can see the portion that's now in the extractor groove of the 300 Win Mag case. This is what will hold the rim on. The rim being securely attached to the case is necessary for resizing. The first version of the converted 300 Win Mag, with the epoxied rims, failed at this step. While these cases are already sized, I'll size them again for the sake of testing. Just like before, I'll first size without the expander. But before I can do that, I need the correct shell holder. The number 18 that comes in the lead die is too small to fit the rim. When turning this on the lathe, I left the rim oversized, roughly 30 thousandths larger than it should be for 11mm Mauser. Due to that, I went out and bought an RCBS number 22 shell holder, which they list as working for 11mm Mauser, but also for 43 Spanish. The rim on the 43 Spanish case is about the same size as the rim on this case, and it fits in there well. I'll size the case. And the true test will be whether it can be pulled back out of the die. That worked. The swaging has essentially made the case and the rim one piece. To finish this case, I'll add back in the expander. Then I can expand the neck. So why did I make the rim oversized? Spec for 43 Mauser is .586. On these rims, I only skimmed it in the lathe for a diameter of .625. The last time I shot this rifle was with converted 4570 cases, and I was having a lot of trouble with the cases not extracting. I think that the extractor on this rifle is out of spec, maybe bent, and therefore it's not able to effectively grab the rim of the cases. But as you can see, the larger rim not only fits in the extractor, but it will chamber. An extractor sign. Now to load it up, so I can test this at the range.
Yeah, it's not bad. And this is a good example of a going this way when I was coming down. Like a good. Yeah, you don't want to point it that way. Because I always use this leverage. Right?
That extracted.
I kind of have weak fingers.
The rim looks like it did its job.
I need that. Right. So remember, your body, you put shit wherever you can move the gun. You don't have to. You're in the triangle. It's just on the far right.
Making these cases is no easy task. Even with the swaging dies already made, each case and rim needs a few minutes of machine time to get them to shape, then the time it takes to swage them together, and further machine time to get the rim to dimension. But with these made now, they should be good for many loadings and many resizings to come. Thanks for watching.